So we've been talking about piecewise functions. We've talked about interval notation and how to write domain and range and all the key feature information intervals into interval notation. So we've gone through all of that. We've talked about graphing piecewise functions. We've talked about evaluating them, how to do creating piecewise functions from the graph, and even word problems. And we've got complex numbers too. So we've gone through a lot of functions and stuff. So now we're moving into still evaluating, but now we're going to go more in depth with it and more at a higher level of it. So like composite functions, we're going to talk about three different parts of this. So the first part we're going to deal with are going to just be our operations, adding, subtracting, multiplying, dividing. When it comes to our second part, that's going to be dealing with our composite functions, where we're putting a function inside of a function and then evaluating it again. And then when it comes to the last part, we're going to do composite functions when it comes to graphs and tables. And so here again, we're going to do with adding, subtracting, multiplying, dividing. And we're going to actually deal with evaluating those functions. So once we've added them, we're going to evaluate with a certain x value. When we subtract, divide, multiply, we're going to evaluate them with a specific x value. Okay, cool. So let's go there. Let's do that. So first off, these are our rules that we're dealing with. And it's all about the look. Because with it, the first one makes sense, like when it comes to sum, f of x plus g of x, that makes sense. But when it comes to the second part, f plus g of x, people get confused on that for some reason. So what we're doing here is we're going back and we're explaining it, well, not explaining it pretty much. We're just looking at it and saying, okay, these are the exact same things. So here, if you know what this means, you should know what that means. So you're going to have to understand it and remember that pretty much. Like commit that to memory. When it comes to subtraction, that makes sense. This function minus this function. Same thing right here. You have to commit that to memory that they mean the exact same thing. The exact same things. And then so on and so forth. So these here are the exact same. And then these two are the exact same. And with that, because you have to know that, nine times out of 10, you might end up with these instead of the original ones right here. So be prepared no matter which one you get, that you know what you're supposed to do. Now, when it comes to the quotient one, because that's division, remember when it comes to your denominator right here, it cannot equal 0. Because if we have a 0 in denominator, that means it is undefined, which means we can't have it happen. So that means like it's bad. It's like no, wrong, evil. So therefore we can't have it. So that's what we need to find out here. What is our limitation? Like we set the denominator equal to 0 and find out what the value of x is going to be, so that we know x does not equal that number. So we find our division portion of it, and then we say x cannot equal blah. And we find that blah by doing this part right here. When we get to that part on the notes, we'll do it, and it'll hopefully make sense to you. All right, so let's go ahead and move into the example 1, and then we'll be done for example 1 and example 2, and then we'll be done with this first part of operations.